Today we are going to discuss about RC integrating and RC differentiating circuit. There is RC, we already studied about RC circuit. There is RC high pass filter and RC low pass filter. RC high pass filter act as a differentiator circuit and RC low pass filter act as a integrator circuit. We know that a differentiator circuit, that is RC high pass filter, is also known as differentiator circuit, that gives the mathematical operation as differentiation operation. That is inequivalently gives the filter response as high pass filtering action. Differentiator means first you have to connect the input at the capacitor side and output is taken across resistor. An RC circuit can act as a differentiator, that is, the output voltage is the derivative of the input. That's the first condition should be satisfied, and the RC time constant should be very much less than 0.0016 t. That is, the t is the time period of the input signal, and the resistance offered by the capacitor, that is the reactance Xc, is very much greater than 10 times the resistance incorporated in the circuit. These are the conditions to be satisfied as a RC circuit to act as a differentiator. We can now check how this RC circuit to act as a differentiator, how this RC component should be less than 0.0016 t. Differentiator means the input is taken across capacitor and the output is taken across the resistor end. This is the high pass circuit act as a differentiator. The output voltage of the circuit V0 equal to I into R. Assume that the reactance of the capacitor, that is the Xc, should be very much greater than resistance offered by the circuit. Under this condition, almost all the input voltage will be available across the capacitor. So the current flowing through the circuit is mostly determined by the capacitor. So the current I equal to C into dVi by dt. Substitute equation 2 in 1, we will get output voltage equal to C dVi by dt. That is, in effect, is equal to V0 equal to RC dVi by dt. Output becomes the derivative of the input. So high pass circuit can act as a differentiator under this following condition. Reactance should be very much greater than R and RC time constant should be very much less than 0.0016 t. The condition for differentiation, that already we discussed, that RC time constant should be very much less than 0.0016 t. How will we get this expression? That will analyze. That we already know that the magnitude part we already analyzed V0 by Vin equal to, for the case of high pass filter, 1 divided by 1 minus j 2 pi f RC, and the phase angle is given by, if the expression is a complex number, the magnitude and phase angle expression, we already know the expression for the phase angle calculation. Phase angle will be given by tan inverse numerator part b by a minus tan inverse denominator part. Here the numerator part, there is no imaginary term, so the first term becomes 0. Minus tan inverse, this is the imaginary part, that is minus 1 by 2 pi RC. So tan inverse of 1 by 2 pi f RC. That is the phase angle of RC high pass filter. Angle becomes tan inverse of 1 by 2 pi f is the angular frequency, that becomes tan inverse 1 by omega RC. For a differentiated circuit, phase angle should be 90 degree. So substitute angle, that is 90 degree, equal to tan inverse 1 by omega RC. So 90 degree equal to tan inverse 1 by omega RC. So tan of tan inverse means 1 by omega RC equal to tan, taking tan on both sides. So tan of tan inverse means we will get only 1 by omega c, that will taken on the LHS side, that is equal to tan 90 degree, that is equal to infinity, which is not practically realizable. So what we'll do, we will select the angle nearly to 90 degree to satisfy the, so we choose a higher value for 1 by omega RC. Let 1 by omega RC should be very much greater than 100. 100 is slightly greater than 90, which gives a phase angle of tan inverse 100. That means 89.42 degree. A practically acceptable condition, that is 1 by omega RC should be very much greater than 100. That means 1 by omega is the angular frequency. That means 1 by 2 pi f RC very much greater than 100. So taking this 100 on the by rearranging this equation, what will get RC is very much less than 1 divided by 2 pi f into 100. That is, for RC very much less than 1 by f is the time period. Frequency equal to 1 by t, so 1 by f equal to t. RC very much less than t by 2 pi into 100, that is RC is very much less than, by solving this expression, pi equal to 3.141 divided by 2 into 3.14 into 100, that becomes the term, that is 0.00160, where capital T is the period of the input signal. RC is the time constant of the circuit. For a RC circuit to act as a differentiator, RC time constant should be very much less than 0.00160. That is the condition to be satisfied, that I already explained. High pass filter to act as a differentiator circuit, RC time constant should be very much less than 0.00160. Next we will check RC low pass filter. But how will you get the low pass filtering action? By interchanging the resistance and capacitance, we will get the low pass filter action. In the case of low pass filter, at the input side you have to connect the capacitor, and the output side, at the input side you have to connect the resistance. In the differentiator case, already we are connected capacitor at the input and the resistor at the output, and the vice versa, that is the input is applied at the resistor and means that circuit is called low pass filter. Ineffectively, that is called integrator circuit, and the output is taken across capacitor. This circuit is called integrator. Then what are the conditions to satisfy the circuit to act as an integrator, that we can check? The circuit to operate as an integrator, the circuit diagram, all of you know that the resistor is connected at the input side and the capacitor is connected at the output side. The corresponding mathematical operation we are getting as integration operation, and the corresponding filtering action for this circuit is low pass filtering action. In the case of integrator, output should be the integral of input, Vi dt. That is the first condition. Output is the integral of the input. Then the second condition is that RC time constant should be very much greater than 16t. And the third condition that should satisfy is that resistance of the circuit, that is the input side, the resistance of the circuit is very much greater than 10 times reactance of the circuit. These are the condition to act as a integrator. The RC circuit to act as an integrator, output should be the integral of the input. RC times constant should be very much greater than 16t, and resistance of the circuit should be very much greater than 10 times XC. So we need to check the RC circuit to act as a integrator condition. RC circuit act as a low pass circuit that we already discussed. In the case of integrator, this is the circuit we already discussed. Output voltage is equal to 1 by C integral I dt, and the output voltage is directly proportional to the input voltage V in dt. The value of R should be 10 times more than the larger value of, that is XC. R is very much, these are the condition we already discussed. The input voltage VI equal to IR. Capacitive reactance is negligible in this case. So I equal to VI equal to IR or I equal to VI by R. By substituting equation 2 in 1, we will get output voltage. Equation 1 means, this is the equation 1, output voltage equal to 1 by C integral I dt. By substituting equation 2 in 1, we will get output is the integral of the input voltage. That is the, in the case of integrator. The condition for integration that we already studied, RC time constant should be very much greater than 16t. This is the proof for analysis for that statement. That is gain of the low pass filter we already derived in the previous class. V naught by Vn equal to 1 by 1 plus j 2 pi f RC. So the phase angle of this circuit is minus tan inverse 2 pi f RC. Angle, as in the case of differentiator, as in the case of integrator also, phase angle required is 90 degree. Take tan on both sides. Tan 90 becomes infinity, which is not a practically realizable situation. So we choose a higher value for omega RC. Omega RC should be very much greater than 100. Then the phase angle becomes slightly less than 90, that is 89.42. 2 pi f RC, the omega RC means 2 pi f is the angular frequency. RC should be very much greater than or equal to 100. F equal to, we already know that 1 by t, 2 pi by t, RC very much greater. By rearranging this equation, we will get RC greater than or equal to 100 into, by cross multiplying t to the numerator side by 2 pi. So the RC time constant should be greater than or equal to 16t to perform the mathematically calculating the exact value is RC equal to 15.9. So we are approximating 15.9 to 16. So the condition for RC circuit to act as a integrator is that RC should be very much greater than or equal to 16t.